Our next speaker is Mr. Bruce Nordman. He's a research scientist with Lawrence Berkeley National Lab, and he will be talking about Internet Standards and Interoperability. Welcome, Bruce Nordman.
Well, thank you for inviting me here. It's a great pleasure. I was tasked with addressing the topic of interoperability, and as the previous speakers have noted, IoT is such a sprawling, multidimensional topic area, and we're in relatively early days in understanding it, that any discussion is necessarily just a single slice through it. So my slice is informed by the perspective of energy use, and so things I say may or may not apply to domains outside of that. But I think it's a really interesting example of how communications technology intersects with energy, because energy and communications are both highly sprawled systems, very technologically informed. They're really underpinnings of our society. And the way that they intersect and interact is really interesting and I think important. Lawrence Berkeley National Lab mostly works on basic science. We're next to UC Berkeley and Berkeley. But we have several hundred people who work on energy use in buildings. And my particular focus area is electronics and networks, which I've done for 20 plus years now. The symbol, of course, on the left is the power symbol, which is sort of interesting and symbolizes this great interconnect between energy and electronics and technology. Because if you look at company logos, for example, there's a huge number of companies that want to be cool and tech because they're electronic gadgets, and they'll throw the power symbol into their logo. And I've actually made a special study of the power symbol myself, spent several years on that. If you don't believe me, check Wikipedia. So I'm hoping to have some time for questions that I don't talk too long, so keep some questions in mind. So why does an energy person care about interoperability? So fundamentally, when you don't have good interoperability amongst devices that use energy, you end up wasting energy, you waste money, and you produce more carbon. And those are all bad things to occur. And in a lot of cases, when you want to save energy, you put in better windows or better lights and such, and you have to spend money to save energy. But if you have better interoperability, it's actually cheaper out of the box in addition to saving money. So it's a really, really important thing for trying to save energy to work on interoperability. And even if you are in a lucky situation where all of your energy is carbon-free, if you're wasting energy, you're still wasting money, which is a bad thing. So you always want to care about it no matter where your energy comes from. So I usually bicycle to work, and it's uphill. So since I'm bicycling slowly uphill, I look down and I see this manhole cover. I've seen this manhole cover for decades. And every day, it's always misspelled. Now, does that really matter? No, because I can understand what it means. And you can sort of understand many, many decades ago how it happens. You know, you're laying out the type and it's backwards because you're casting it, and you're doing it quickly. So many decades ago, somebody did this, and now it's still misspelled, and decades from now, it will also be. So mistakes can last a long time. And while people may replace their phones every 2 years, an awful lot of things in buildings last for 10, 20, 30, 40 years. And if you put in the wrong technology that's not interoperable, we will waste energy for a long time. So it's really important from a building's perspective to get interoperability right. So what do we actually mean by this? Well, the word itself essentially means to work between or to function between. So what's really important about an interoperable device is not so much the device itself, it's the technology standard that sits in between devices that enables them to be interoperable at all. So that's really the magic of interoperability, is those interface standards. And they're of all sorts. Sometimes they're physical, sometimes mechanical, electrical, and they're all defined by these technology standards. And in order for things to be interoperable, the standard has to exist. If it doesn't exist, no company can make a product that complies with it. We don't want too many of them, as Vint noted, and they have to be of good quality. And all those things have to be present before we have a hope of things working out well together. So just a few things to clarify. People often use the words energy and electricity interchangeably, but of course electricity is only part of the energy picture. I work almost entirely in electricity, so that's what I'll focus on. I also only really address residential and commercial buildings, but they are about 70% of electricity use in the US, so that's a good chunk of it. The term Internet of Things always sort of bothers me, although I'm not proposing a replacement for it, because by the definition of the word thing, everything that has ever been on the internet is a thing. So I sort of sometimes think we should talk about the Internet of Things and the Internet of Other Things. But obviously there's some distinction between the stuff that used to be on the internet and the stuff that is coming onto the internet. And the key thing is that information technology, as we've known it, is only to do with the information world, which is sort of disconnected from the physical world. You go to a website, but of course there is no physical site at that website. It's an abstract concept. But the whole value of IoT things is that they are connected to the physical world, and so that brings up a whole additional set of semantics and data issues that need to be addressed if things are going to be interoperable for how we represent the physical world in the information world, and vice versa. So that's, I think, the key to a lot of the challenges we face over the coming few years is how to incorporate that physicality into our network technology. And if you consider information technology itself, the energy that uses, it used to be a rounding error in electricity use decades ago, but 2 years ago I added up the various estimates of what all electronics devices use in the US, and it's about 14% of all the electricity used in residential and commercial buildings. So that's not a trivial amount. Now some people think that data centers, like the ones that Google and others operate, are where most of this occurs. It turns out it's only about 9% of electricity used in the US occurs in data centers. So while it's important to make those more efficient, but the people who operate them have done an enormous job of making them very highly efficient, the other 91% is actually where we can save the vast majority of electricity in IT devices. So how do we get to interoperability? I sort of think of this as some necessary ingredients that you have to have if you're going to have a good outcome, some known ways that we can fail in providing interoperability, and then we have to have some sense of a path forward as to what to do. We certainly know from past experience that even such a thing as an electrical outlet plug, in Europe we have lots of differentiation. Luckily in the US we have really a fairly small amount of variation for our 110 outlets. And that's, of course, a good thing. We save a lot of money, a lot of convenience. And the really important thing about interoperability is that when it works well, you don't even notice it. You know, there was a time when we had, a dozen major different formats for email addresses, and at one point we went to one, and nobody ever goes back. And it's just a distant, bad memory that some people have that things used to be much worse. So, this is supposed to be, a cutting-edge conference, but unfortunately I look back and I've been using the same slide for 8 years now. But hopefully it still is resonant. I think a critical first thing to get to good interoperability is to have a goal. It's not an attainable goal, but we should try to get as close as possible, that any device should work with any other device in any space. And that you only want to back off from that when it's clear that there's reasons why you can't. Now, there may be some industrial IoT devices that will never interact with my phone, that's fine. But as far as general things that people interact with, we should try to make everything work together as much as possible. About 10 years ago when people started talking about the quote-unquote smart grid, you would have utility people talking about home area networks. And I kept thinking, why are they proposing that we have a technology different in houses from in other building types? That makes no sense. It's a terrible idea, and yet people still continue to use that sort of terminology today. Really good technologies are universal. We only have to think about things like Ethernet or USB or Wi-Fi. They're the same everywhere. We don't want technologies which differ between countries because people and devices move between countries, either before or after they're sold. And so it only impedes doing the things we want to do if things are different. A lot of these devices last across time, so we want them to be interoperable when you first bring them out, and decades later, ideally, they should still be interoperable. Traditionally in buildings, the lighting system and the heating and cooling system and other systems in buildings don't talk to each other. We need to have things be unified across electricity end uses. And also, the 7 billion people on this planet are enormously diverse, and everybody needs to have the opportunity to interact with these devices, not just particular subsets of humanity. So another critical thing is having a coherent, simple layered model at the foundation of your system. And we certainly know that in internet technology, the OSI model, whether it has 5 or 7 or 8 layers, is critical to that, to isolate the details of physical layers from application layers, and also do other sorts of isolation of complexity, which make things less expensive and more flexible, and critically allows technology to evolve, as we've seen our internet technology evolve over time, while still being working. And an essential part of this is to have this narrow waist where everything comes together in the internet protocol. So that's been an essential component of networking. How do we then apply these sorts of principles to IoT devices? So of course the area that I work is in energy, and so I believe it's essential to have a layered model of electricity that's analogous in some ways to our layered model of communications. And I think there are other dimensions of IoT that will also do well to have layered models, but I haven't yet figured out what those are, so other people in this room should help work on that. So in electricity, what you want to do is the lights up here want to get electricity, so they want to know how available power is, and so you want to digitally manage how we move electrons to the lights so they can then use them. The lights also need to have functional control protocols where they know, do they want to be on, do they want to be off, do they want to be dimmed, and those higher layers are the standard IP layers that we use today, unchanged, application layer protocols. And you want to reflect the availability of electricity to the light as a price, because that's the way we address resource scarcity in a general way. And so we need to apply that same simple approach we've used for hundreds of years for other resources to electricity. And then each individual device can integrate those two things in how it operates. So for example, as the electricity price rises, or maybe the grid goes down and we're only being powered by some local generation, the lights right here, they're shining on me, so they should stay at the same lights, but the lights over you, maybe they should dim, But each light can decide for itself what to do, and so this is an analogy to the narrow waist of the IP protocol to isolate the complexity of how we provide electricity to devices and how they control themselves functionally, so that we can move electricity to a network model and get great benefits just from that, in the same way that we moved communications from a centralized model to a network model. And if anyone wants to talk about this further afterwards, please contact me. But what this could mean is that just as in a building you have your Wi-Fi network and your Ethernet networks and other communications networks that all interconnect and then eventually connect out to the wider internet, a building could similarly look like a network of power domains with end-use devices and attached to local generation and also attached to utility grid, where all these connections could be plug and play, and electricity might flow in different directions at different times. And this really allows you to do new things with electricity not possible with our conventional technology, in the same way that network technology allows you to do new things for communications that were not possible with the old phone system. So I call this model local power distribution, to sound like local area networking. It's a network model of power, and the smallest organizational unit comparable to a subnet in IP networking is the nanogrid. So the converse of that is the smart grid. So I've been paying attention to the whole idea of the smart grid for about the last 10 years, and you commonly come across diagrams like this. This is completely unlike the layered model and the types of models that people use in the IETF and other network standards. This is crazy, okay? There's no structure here. Such a technology is guaranteed to be highly expensive, guaranteed to be brittle. It's probably going to have huge cybersecurity challenges. Now, if you're a company selling into this market, that may all be good, because you can then sell lots of products and services. But for electric utilities and for people who are customers of utilities, it's terrible. We need to learn from how things were successful in communications and apply those to our energy systems. And today, in general, we are not learning those lessons, and that's kind of sad. So, the converse to overwhelming complexity is to make things simple. And certainly companies like Apple are successful in the market because they make things simple for people to use. And a lot of network technologies work well because they're simple and efficient. Simplicity is not necessarily easy. It can be really hard to craft something that works well as simple, but once you do it, it's wonderful. So a lot of times I run into cases where people sort of presuppose complexity and say, and design systems that have lots of parts to them, when it seems to be quite possible that a much simpler solution may exist, and you should always start with trying to make things as simple as possible first. Another issue which really relates to this privacy topic or in security, which the other speakers mentioned, is a lot of companies that sell IoT devices want to immediately connect them to the cloud. I think one reason they want to do that is so they can monetize data and have new revenue streams. And if companies want to try to do that, they of course have that right. But we shouldn't have such things embedded in the core technologies. That should be something optional that people may choose to do, may choose to share only bits of their data, or none at all if they want to. But technology should not be built around requiring that kind of operation. And actually, the network model of power that I mentioned earlier isolates the complexity of what goes on inside of a building from the complexity of the grid, so that you really don't get visibility. The grid doesn't have visibility in the building and vice versa. So that really protects privacy and security in ways that the traditional approaches to grid architecture fundamentally cannot do. So, and also of course that if you lose your internet connection, then your device may no longer function, which is really a not good thing to do. So, related to this is people designing technologies around business models. And certainly in the whole electric utility area, all kinds of companies are trying to figure out ways to monetize money out of the electricity system, and then say, let's design technologies which implement that business model. The internet protocol was not designed around a business model. It's designed to be useful for all business models so they can effectively compete with each other, not to require certain directions based on the needs of the technology. Another area that I've worked on is how we communicate with devices. And I spent 3 years studying how we turn things on and off, which may sound trivial, but I made really good use of that time. And this was about 15 years ago, so things have changed. But you find really sort of peculiar things. Like you find a power button that's red. Of course, red buttons symbolize, like the red telephone between the White House and the Kremlin, that there's something wrong. So why would you make your power button red? Also, if you notice, it says on-off above it. But the symbols above the on and the off don't correspond to on and off. In fact, the one above the off word is the on symbol. And this company has been making the same sort of, for over a decade, and nobody seems to have noticed that these symbols actually, what they really are just trying to do is saying this is the power control, and if you use it, you will change the power state of the device. But companies continue to make these sort of peculiar power controls which can confuse people. And like if you approach a traffic light, you don't wonder, does red mean stop or does red mean go for this traffic light? It's always the same, because if they weren't, they wouldn't be interoperable with us. Another kind of curious thing is that I found some user interfaces that use Z's to indicate sleep, the Roman letter Z, but the only companies I found that were doing that were based in Japan, where of course they don't natively use the Roman alphabet. So it's an interesting, fascinating cultural exploration to figure out how people turn things on and off. So the solution to this, which we use every day, is to have standards for things that we commonly interact with. So that whether it's traffic lights or automobile controls or the tape transport controls we use to control media, they were of course invented for magnetic tape, which we're no longer using, but they're durable over time in the sense that they are readily adaptable to different media. So we need to have a much richer set of these so that we can interact with devices, no matter whose devices, and always have a similar enough consistency that we can readily interoperate with our devices. Curious thing is, for 5 years, there were actually no star and pound keys on keyboards, on phone keypads, and there was a committee that actually created them. It turns out that even though we use them essentially as punctuation during phone calls, they were invented by AT&T, who was prohibited from being involved in phone calls by law, and so in fact they could not make any statements about how they were intended to be used, which is why today there's really nothing you can assume about the difference between a star and a pound key based on them because of this sort of legal restriction on the origin of the telephone keypad. Anyways, so another sort of corollary to all this is that while commonly in technology you get engineers who design a technology, which may be great, and they have certain conventions and language and terminology and metaphors they use in the internals of the technology, then you build a product and a lot of those things eventually then flow up into the user interface in ways which are not necessarily good. For example, in early Windows systems, there was 2 different sleep states, neither of which were called sleep. One was called standby, one was called suspend. And there's no way you can rationally determine which is the higher state between standby and suspend, because they have no logical relation to each other. And furthermore, if you translate that to a different language, it's going to be even worse. So what you really want to do is you really want to ideally design the user interface first, and then design your internal technologies around the needs of the human beings, because we want the devices to serve our needs, not the other way around. So what do we do moving forward? So as was noted, we have this huge diversity of protocols, both physical layer and application layer. And for the foreseeable future, we'll have to muddle through and have a lot of gateways between them so that devices that don't natively support the same protocols can interoperate with each other. That's not a good outcome. That's just the least bad outcome to have. But ultimately, we really do want to move towards a standard unified data model about physical world devices in the same way that we, for example, with ASCII, we have a standard way of representing characters. And then create ways so that old protocols can be translated to this sort of standard data model or out of it, and eventually we can have devices which natively use that. And over time, it will take many decades, we can move to a state where most devices are using that new, better standard data model, and that should really be designed mostly from the ground up, not encumbered by the bad characteristics of existing technologies. And we really need some sort of neutral organization to be the one that creates and maintains that, because all these existing standards organizations have vested interests in these existing protocols. And I actually suggested to ISOC about 10 years ago that the Internet Society take up this challenge, because unlike all these other organizations, you're not beholden to one of these existing application layer protocols for buildings, and so you are independent and global, and so perhaps actually the best suited to creating a body which does this. Just an idea. So a final thing is that on IT networks, we have network services that are essential for the networks to function well, and I think we need to create new network services for some of these physical world processes, and I'll get to that in the next slide. So about 2 years ago, I started looking into data model issues, and I took about 20 different standards out of maybe 100 which I might have looked at, and even something totally mundane as I want to say that this is an iPhone 5, it's an Apple iPhone 5S, a manufacturer and a model. All these different standards had different ways of naming and representing that fairly trivial information. Most of them didn't take into account of the fact that you may have a Samsung Galaxy 3X, and so it's actually a 3-part bit of information, not just a 2-part. But a lot of them had other things in terms of, do you include spaces or not in model numbers? Some of them included URLs. There's all this diversity. Obviously, nobody's paying attention to how other standards are doing things. So it's really just, at the moment, chaos, and we need to have some way to bring this to some coherency so that things can be more interoperable. So in this network services, we have things like DHCP, DNS, file sharing services, directory services, device discovery services that operate on networks that just make things work a lot better. And I think we need similar kinds of things for example, an occupancy server in a building so that one device can collect information about where people are and then share that with the devices like lights or heating, cooling systems or security systems. They may want to know things about who the people are in the building. And this would be a service within the building, not a service outside of the building. Or location, if you want to discover devices that are within 10 feet of you, if there was one device in the one server in the building that knew where everything was, you could then do queries about device type and location and get back some sense of who you should be trying to communicate with and not try to communicate with the devices. For example, don't try to communicate with the light that's on the other side of the wall. So in summary, there's huge interoperability problems today in the IoT domain space. It is only going to get worse for the coming few years, but we certainly have the opportunity to start now to making things a lot better, and it will take time and hard work, but I'm an optimist, and I think that we can do that. I don't know why I did this. I spent about an hour coming up with anagrams for interoperability, and those are some of the ones up there. So anyways, thank you, and if there's time for questions, I'd be more than happy to take some questions and answers.
Yes, we do have time for Q&A.
So, Chris, a couple of things. First of all, your point about how many engineers does it take to turn a microphone on? So about user interfaces, one of the things that I worry a lot about is people with various kinds of disabilities. So if you're blind, it doesn't do you any good to have a whole bunch of icons because they can't see them. Have you given some thought to how to cope with this variety of needs that people have to interact with these devices?
Yeah, when I studied power controls, how we turn things on and off, I did try to address this issue of accessibility. And for example, I would meet people who said, my computer monitor changes from green to yellow when it goes to sleep, but I'm colorblind, and because it's a cheap bicolor LED, I can't tell the difference. And so obviously people are designing products that are not accessible even on fairly trivial ways. I actually wasn't able to find a lot on that I could have put into the standard that I wrote, but it's definitely a huge issue. It's going to be more so in the coming years, and we need to develop conventions and technologies for that.
So if I could follow up with one more. I think you implied this, and that is that some of the devices that we put in our homes and offices and everything have long lives. And the software that's in them probably has bugs, which means that during the lifetime of this device, we have to find a way to fix the bugs. So although neither of us apparently put on our slides the ability to update the software, it seems to me that that's a very highly necessary thing. But now we have to worry about whether the software that goes into it is coming from a legitimate source as opposed to somebody who does not have your best interest at heart. So where does that fit into your universe?
Well, so the way it fits in my universe is I can dodge that because that's a general problem that is not an energy-specific one. And I'm really just trying to solve the energy-specific problems. But I agree, it's a huge problem.
You can't duck this because these devices get embedded in things that may not be very visible. I mean, you could walk into a house and discover there are a bunch of different devices that you can't even see. And I did this just a couple of weeks ago. I ran one of these little Wi-Fi detector thingies and discovered that there were 4 or 5 things that were doing Wi-Fi that I had forgotten about that are hiding in drawers and so on, and whose batteries hadn't died. So you have a question way in the back.
Oh, okay. We have either 1 minute or 0 minutes.
1 minute, yeah, you can, I'll run.
Hi. Is it morning? Hey, good morning. Aaron Hughes. It seems that you, Bruce, Vint, and Karen are all bringing up very common issues. You know, some related to interoperability, some related to security, some related to longevity of the device being up and enabled and on the internet and maybe not being upgraded. But the underlying issue is that we don't have a body that helps develop standards for consumer electronic devices. While we have things like the IETF, which should work on standards such as security for vehicle-to-vehicle communication and potentially HomeNet, interoperability seems to be led by the large players simply developing a standard and the small players follow. You hinted that you suggested the ISOC should start an organization to help define these standards and maybe create a certification for these CES devices, but it seems like we're not really doing anything about it. How do we push this forward from suggest ISOC lead creating such a body to, you know, having some organization actually create that body? Because our biggest problem is actually time. If we build a home today and we fill it with, say, you know, some vendor devices of light switches, they're going to be in that home until that home gets destroyed. And that could happen today. So if we don't get a body created really soon and start informing the CES vendors that there are standards that must be followed, this is going to be a cowboy mess of proprietary protocols and standards and security.
Yeah, well, I should say that what was the Consumer Electronics Association, which is now the Consumer Technology Association, would say that they do technology standards, which they do, but they don't address what you identify needs to be done. It certainly would take a group of people who have influence to create such a body, and I'm not one of those people. And they just have to stand up and start doing it. I don't know how else to do it. And I guess have companies that would also sign on to such an effort with an independent body. I think we're out of time, so.
I had to put Karen Rose on the spot here, but Karen, do you have any comment on that in terms of the Internet Society helping with this issue?
We need a universal button for microphones, interoperable button for what's on and off. You know, I don't have any really, you know, comments about whether or not this is something ISOC should do. It would be something that our board would need to consider. But one question that I have about that is, would people follow it, or would it be just another standards effort? So the cartoon that I had on one of my slides, if any of you saw it, you know, is a cartoon that says there's 14 standards out there, and there's two people that say, that's terrible, we have to have one standard that's going to cover all use cases. Okay. So then the next one says, what's the result? That there's 15 standards out there instead of 14. So one of my questions is, what does it really take to pull enough people and players together where it is an effort that results in what the intended outcome is? And I'm not as familiar as market dynamics in that space to understand what it would take. I mean, there's a lot of economic issues as well going on in this. I mean, I think there's a lot of people doing their own standards so they can try and, you know, be the dominant standard. So those are some of the questions that I have. What would it really take? What's the center of gravity that you need to have around that kind of process for it to make sense, rather than be yet another effort? Because that's one thing I think we see in the IoT space as well, is that there's a lot of these sort of efforts coming together to try and create standards, but there's 1,000 flowers blooming. So what does it take to break that cycle?
Great, thank you. Thank you, Karen.